Imagine if we powered the planet with lightning? Every time you watch a thunderstorm outside your window, you're witnessing the energy of an atomic bomb. Now imagine harvesting that raw energy and using it to power the planet. Let's say, like solar panels, you could install a small lightning harvester in your backyard. It might be ugly, but pretty soon you'd be jumping for joy every time there's a lightning storm. All you would need is a single bolt of lightning and you could power your house for a whole month. That would be a shocking savings on your electricity bill. First, we'd install massive metal towers at some of lightning's highly visited areas. Imagine monolithic towers rising from Lake Maracaibo in Venezuela. This lake is the most electric place on Earth, and during the peak rainy season, it's possible to see an average of 28 lightning flashes every minute. We'd also install a lightning harvester next to Santa's Tower in the Swiss Alps, winning the title for most frequently struck. If all 100 bolts of lightning were collected at Santa's Tower, that would be 1,000 million to 100 billion volts of electricity every year. Still, we couldn't just rely on these electric hotspots. It would largely depend on you, the average person, to harvest lightning for electricity. Much like solar panels, homeowners would elect to install lightning towers in their backyards or on top of their houses, keeping the source close to where it's needed. There would also be small lightning farms scattered around rural areas, much like wind farms today. These large metal structures would be an eyesore on a normal day, but would be magnificent during a storm. The countries where lightning strikes the most, the United States, India, and Colombia to name a few, would become the centers for lightning harvesting. After using this clean energy to power their own countries, they would sell off the rest of the energy to other nations. Thunderclouds are made up of millions and millions of water droplets and ice which collide together. During all of those collisions, electrons are knocked loose and gather at the bottom of the clouds. This creates a negative charge in the lower part of a cloud while the upper cloud becomes positively charged. The separation of negative and positive charges results in an electrical field. When this electrical field becomes strong enough, the surrounding air ionizes, creating positive and negative ions. The negative ions create a path to Earth, called a step leader. When the negative ions in a step leader find the positive ions of an object on the ground, let's say a lightning harvester, it strikes. And in this scenario, that energy is collected and stored for use. But how close are we to developing this technology? Well, not very close at all. In 2007, Alternative Energy Holdings designed a tower with grounding wires and a capacitor. But their attempts to harvest energy from lighting failed. The project was too costly and there were many limitations to its success. Lighting is, by nature, sporadic, so it isn't a sure thing that a bolt will hit a harvester during a storm. If it does find its target, lighting disperses energy on its way down to Earth. So a tower would only capture a fraction of the energy from a lighting bolt. The bolts themselves are unpredictable. This would require a specially engineered collector that could withstand such a wide range without exploding and causing fires. Even if we were able to successfully harvest lightning and store the energy for future use, we'd only be able to power 8% of American homes. That's a far cry from powering the whole planet. But it's still clean energy and could be a piece of the entire renewable energy puzzle. If we really wanted to make lightning our sole source of energy, we'd need to figure out a way to control the weather,